Okay. So whenever they ask for sine theta, cosine theta, or tangent theta, they're referring to a specific angle, and then you talk about opposite, hypotenuse, whatever. Okay. So sine theta for this specific example, the opposite is going to be 7 over the hypotenuse, which is 25. Okay, so this is just 7 over 25. And we'll do the next example on paper, or the first problem on paper. This is just a quick example. Cosine theta, there's the theta. We said it's going to be adjacent over hypotenuse. So the adjacent side, the side next to it, over hypotenuse, right? That would be 24. That's a weird 4. What is that? Over 25. Okay. So what is tangent? What do y'all think?
7/24.
Yeah,
Oh,
it's going to
sorry.
be
7/25.
opposite. No,
Yes.
you're right.
Yeah,
Opposite
seven over
over
24.
adjacent. 7 over 24. Okay. And then cosecant we know are the reciprocals of the original three. So you would just put hypotenuse over opposite, which is the reciprocal of sine. So 25 over 7. Secant is hypotenuse over adjacent, so 25 over 24. Cotangent, just flip over tangent, and there it is. But you have all the definitions, and I sent those notes to you as well. But anyway, is there any questions on dealing with the theta? Did it make sense?
Mhm.
Okay. So let's do the first one right here on paper. So we're going to do this one just a second. You guys cool on the first example though, right? If not, let me know. I'm just going to write the simple instructions. Find cosine theta and sine theta. Triangle. They gave us a right triangle. Let me switch over to the notepad here. Write that a little better. So that'll be, I didn't draw it very well. The missing side, it's gonna be, let me see. I think it's hypotenuse. Yeah. Okay. So we have, in order to find cosine and sine, we need hypotenuse. We can't solve it, right? So we have missing side. So we know that a squared plus b squared is equal to c squared. Using Pythagorean, we can find the c. So this is c.
Mm.
So we know that a is 3, b is 4. My triangle is drawn horribly, but this is supposed to be hypotenuse. Okay. Which makes sense because if it wasn't, we would have one of these already. So plug in your three, plug in your four, solve for C. So that'll be 9 plus 16, which is 25, right? So square root both sides. C is 5.
I know that the drawing is a little off, but would it make sense to cross out the 4 and trade it for C? And then wherever you have C at currently and trade it for 4.
You mean flip these around?
Yeah.
Yeah, I think that would be it doesn't matter. I mean, this is how they drew it, but yeah, let's do that. Why not?
Yeah, because I messed up. I did the opposite, so I thought my hypothesis was 4. So then my formula downstream just went
I mean, as long as we understand that we're
at
looking for the hypotenuse, it doesn't matter, but I think that picture just kind of sucks. So this will fix it. I agree.
Okie dokie.
Okay, so we have 3, 4, 5. So now what is cosine? What is sine? They gave us a theta here. Because we need to know where the theta is before we answer. What do y'all think?
like, what's the answer? Is that what you're asking?
Yeah, what's cosine theta?
Oh, sorry, I was doing the same.
Um, yeah, the A over H. So
0.8.
3 over 5.
3 over 5. Yeah, so adjacent side over hypotenuse. What about sine?
Uh, 4 over 5.
Now opposite over hypotenuse, 4 over 5. Yeah. Any question on what we just did?
And the A squared plus B squared equals C squared doesn't matter where the numbers are positioned or no?
As long as you know what is what, right? So if we knew that we're looking for a hypotenuse, then the other two have to be the legs, the A and B. But if it's not, it has to be clear.
Okie dokie.
Okay. We'll move on to two. You guys have no questions on one. There's no rush, so just let me know. So given an acute angle theta, if tangent theta is equal to 5 over 12, find find secant to make it obvious this time. Oops. So there's theta. So opposite over adjacent is our tangent, right? So that's where they go. Because we know tan is 5 over 12, which is going to be opposite over adjacent. Secant theta is, excuse me, hypotenuse over opposite, right? Yeah. So,
I thought it was hypotenuse over adjacent.
yes, yes, it is. Yes, yeah, it is adjacent.
I made up a funny little saying in my own head. Cho Sha Koa for the reciprocals.
Those mnemonics help, man.
Yeah.
Those are good ideas. Okay. So we got to solve for hypotenuse again, right? So it doesn't matter which one is A or B. So solve for C. Okay. It's going to be
25.
25 plus 25 plus 144.
169. It's 13.
Yeah, I think so. I think you're right. The square root, both sides, that should be 13. So hypotenuse is 13. So now we can answer the question, right?
13 over 12.
Yeah, hypotenuse over adjacent. Any questions on the algebra or the triangle stuff? Okay. So make sure you open up your unit circle for the next one, next example. If you don't have it memorized, which I won't make you, but at least have it open. So find the exact value without a calculator. In other words, use your circle or know how to find them. Part A is tangent of pi thirds minus secant of pi fourths. Yeah, you can spread it out. That's a good idea. I wonder if I can paste this. So here's the one in the notes. This has the secant, cosecant for these basic angles in the first quadrant. I mean, you don't need them because you can use the circle, but remember that tangent, let's write that as tangent is equal to sine over cosine, right? So you could do this. And secant is what? 1 over sine, right? Over cosine.
Um, yeah.
Okay. So just find these on the circle and then you'll be good. We just do some algebra. So sine of pi thirds on the one they gave you or the circle is going to be, let's go to 3 over 2 over 1 half minus 1 over cosine pi over 4, which is root 2 over 2. We're just plugging them in from the circle. You guys okay with that? Nothing fancy. So let's just play with the fractions and make it pretty. These twos will cancel, leaving me with root 3. Now on this guy, we should rationalize because we don't like square roots on the bottom. So that will be 2 root 2 over 2, which will cancel that, leaving me here. So this is we used to call this the back of the book answer. Like completely, um, what's the word? Cleaned up, I guess. So dividing fractions is the same as multiplying by the reciprocal. Those cancel, leaving me with this. 1 divided by this is the same as multiplying by the reciprocal, so it just flips over, right? Once it's flipped, we shouldn't have a square root at the bottom, so we're basically we're forcing a square at the bottom. So when you square a radical, it ends up as a 2. That's why I introduced this, because we can always multiply by a form of 1. Once that's done, it becomes a 2, right? Square root 2 times square root 2 is square root 4. Square root of 4 is 2, so this cancels the other 2. So this is the pretty answer. Technically, any of these are the answer, right? It's just that we had to do a little algebra. We did some fractions here. From here to here, we'll write some notes for you in case you're rusty. Uh, Fraction step. Here to here, rationalize the denominator. That's what it's called. And then we end up with this. Any of the algebra steps or trig steps confusing or strange, let me know. You have any questions?
For our quizzes and stuff, will we be given the unit circle?
You can print it out and use it. It's no big deal.
Okie dokie.
You can also write a formula page for algebra properties and trig properties. Okay. You just know worked out problems like this, like stuff like this. Just like the formulas I gave you before. Any other questions on number three?
You mean the two pages, the trigonometry laws and the algebra properties pages we just got?
Yeah, stuff like that is what I'm talking about for formula pages. Either
Oh,
those exact ones or things that are similar to that.
okie dokie.
Okay. 90 minus 75.
I have a question. Sorry, I got lost in the beginning. I was trying to figure it out. So
Sure.
from the previous lecture, there's two secants. So it's like well, my notes I wrote like the hypothesis over adjacent, and then the reciprocal, the one over the cos.
Yeah, they're
Um,
secant and cosecant.
oh, okay. Secant and cosecant. Okay, I think that's where I got confused. Sorry.
No, that's okay. Yeah, there's six trig functions. It's the original three, sine, cosine, tangent, and then the reciprocals of those three is the secant, cosecant, cotangent.
Oh, okay, gotcha.
So they're really only three, kinda, but well, we say there's six, but they're just reciprocals.
Okay, gotcha. Thank you.
Okay. Um, Make sure the notes I'm using right now. Can you guys see the cofunction thing?
Yes, sir.
So this is the next page after number three. These are all a lot of these formulas I already gave you in the notes from last time, but you should always have them because they're useful. Cofunctions, I don't remember if I gave them to you, but they're here. They don't come up very much, but these are ideas that you should know. That sine is equal to sine of that particular theta is equal to cosine 90 minus that same theta. So for example, sine 30 is the same as cosine 90 minus 30 using this formula, which is where the 60 came from. Tangent is the same as cotan of 90 minus that theta. So if your theta is 12, 90 minus 12 is right here, right? They're just applying these formulas here. So knowing that, that means that you can set this cosine equal to the sine cofunction. What would be the sine equivalent of cosine 75 using this property right here? What do y'all think? And if you don't know, you can write out the formula, right?
Uh, so it would be sine 90 degrees minus theta. So if theta is 75, 90 minus 75.
Yeah. What is that?
Um, Brain is not operating. It's not on today. Did not have enough caffeine.
Oh, that's okay. I don't like adding or subtracting anymore these days.
15.
It looks like 15 to me, yeah. So That means that this is what they want. This is what they wanted. This guy is equal to this, which means that this one is also equal to that same thing. So hard to write with the mouse. That's a 6. Although my handwriting doesn't look much better, which is kind of funny. Anyway, any questions on these cofunction formulas?
No, I think when you write the formula out, it makes it a little easier to understand what the question is asking for.
Yeah, just apply it. It's not a it's not a trick question. But without the formula, you can't really do anything.
The cofunction identities is in the electronic tutorials trigonometry laws page, but it's in rads. It's not in degree form.
Yeah, here it has both of them, but it's
Pretty
you guys
stellar.
you guys can convert back and forth, right? And if not, write both of them. It's okay. All right, let's move on to number 5. I'm gonna do that on paper.
Yes, sir. I have one question.
Yeah, what's up?
For these particular pages of all the notes, would we be allowed to use these during tests? These whole pages?
You can use the formulas like these things, but not the examples.
Like we like have to write them down, or
Yeah, you can write like this stuff down. You can write these. Like anything that is a formula is allowed, and unit circle is allowed, and properties, but not stuff that I worked out or anything that's worked out is not should not be used.
and will we have to take pictures of these as well, like with the notes we have to upload with our test?
Yeah, if you decide to write them by hand, then you would upload that with your test.
But if they're like separate notes that we have, just like always.
Yeah, if you have multiple pages, I mean, I'm cool with that. Try to keep it to like 1 or 2 though, not including the circle, of course.
Okay.
Circle is a free page.
Like 2 pages front to back.
Yeah, I think that should be sufficient for this class.
Okie dokie.
Good to know.
Excuse me. Want to sneeze. Excuse me. Okay. Guess it's a
Bless you.
false alarm. Man, couldn't sneeze. All right, so the next one, it wants us to prove if the statement is true. So here's going to use all those properties I gave you from last time, and they're also on the PDFs I sent. Let me switch over in just a moment. Actually, I'm going to rewrite that. Use fundamental properties to determine if the following is true or false. All right. This is like the first time you actually do any real math, uh, is whenever they ask you to prove something. But most people never get to see what math is supposed to be. which is a shame. Okay, so using all the properties that you know and we've talked about, where I've sent you, prove or disprove, show that this is true or false. Is this left-hand side equal to 1? So the way you prove something is you pick a side and then you apply your properties. The way to do it properly is to state what property you're using as you go. Um, but let's do this here. Cosecant squared, tan, sine, cosine. Yeah, we're good. So let me open those properties I sent you. I think I might actually these would be good, I think. Yeah, we'll deal with it right now. I'm going to change tangent into sine theta over cosine theta. You agree that this is the same thing using I think we call them reciprocal and quotient identities. Oops. Right? Do you agree that these cosines will cancel? And if you don't see it, right, if you multiply everything together, everything would end up on top. This would become a sine squared. And that's it. Cosine stays down there. So that's the quotient property that we applied here. All right, so now you can see it, right? You should see it here, but that's okay. If you're not comfortable with fractions, if you were to multiply everything together, everything would be on top, this would be on the bottom. So, and you only do cancellations when you have products. So just in case you forgot your algebra, if you have products, that's when you can think about cancellation. These are all products. Now, what is cosecant in terms of reciprocal?
It's 1 over sine theta, right?
Yeah. Did you see what's going to happen?
And then they cancel each other out.
We use a reciprocal property right there. True statement. So we showed that it was true. Here we did algebra. Any questions on number 5? All right. Move on to number 6 will be the same type of thing. Okay. Tangent theta times cosine theta equals 1 minus cosine theta. So you pick a side and then you try to make it turn into the other side. Whenever you do these types of things, You want to pick the more complex side because you have more things to attempt, more things to try. And there's not just one way to do this. There's many ways. So you just have to try something, see what happens. You look at the property and say, all right, well, let me try this and see what happens. Um, there's not there's always, of course, the shortest route, but that doesn't matter. What matters is can you use the properties and can you get there? So I'm gonna start with this side because it looks uglier than the other one. Then I'm gonna change this using the ratio. Now we can see, right? This is ratio uh, or quotient, I think was what we called it earlier. Quotient property. Sine times cosine over cosine is just going to cause it to cancel. If you want to cancel earlier, you can. That's okay. But now we end up with sine. There's no way sine is going to turn into 1 minus cosine, right? Like there's nothing we can do here. So this is false. There's no property that you can create to force this into to this. Make them out of tricks. Okay. Anyway, once it gets really simple and you know it just can't be done, just say false. Once you get there and it is true, then you're good. Proving it's false is a lot harder. Proving it's true is more straightforward. Oh, actually, that was. Oh, yeah, that's true. Okay. Anyway, any questions on 5 or 6? We're gonna do some word problems and then we'll take a little break. Mm, okay. Let's do a word problem. I always hated these when I was in math class. My only advice is just read it over and over again and try to figure out what's happening. So a 28-foot slide at a water park makes an angle of 60 degrees with the ground. As it descends into a pool, guess it's all cool water slide. What is the vertical distance from the top of the slide to the ground? All right, so I think it's safe to say that the slide is your hypotenuse, right? I want to know the height. I'm coming down the slide, which is 28 feet long. And this is 60 degrees, right? Yeah, I think
So we're
so.
looking for the opposite length to the 60 degrees.
Yeah, because that would be the height. Because the angle from the ground to
Or sorry, height.
angle of 60 degrees of the ground as it descends. So yeah, it'd be 60 here. We want to know height. So this is when you have to be creative and think about it, right? Like, which trig function should I use? So like, it's not going to tell you which one to use. So you have to remember opposite hypotenuse, adjacent hypotenuse. We obviously have the hypotenuse, so we need to use one of the functions that has hypotenuse in it. And since we're looking for the opposite side, we need the function that has opposite and hypotenuse in it. So you can use sine or its reciprocal to solve this. So sine theta is equal to opposite over hypotenuse. And our theta is 60 degrees, which is equal to the opposite side over 28. Okay, so find the opposite. We can call it x or whatever. Multiply both sides by 28. Do some algebra. We cancel this. So 28 sine of 60 is equal to the opposite side, which is our height. Probably should have called it h, but well, no, h would be confused with hypotenuse. I think x would be fine, but who cares? At this point, we need a calculator, and I forgot to charge mine again. Let's see if my phone one will work. Twenty-eight.
14 root 3.
True. We could use the circle and then use our calculator. So it'll be 28 times sine of 60. Yeah, you're right. Root 3 over 2, which would cut this in half. 14 root 3. So what is that as a decimal? So we need the calculator still. We got the opposite side as 6 point, I don't know, we'll round to 2 decimal places. Any questions on 6?
Yes. How did you get the square root of 3 over 2 for the sine 60?
And 60, that's just on your unit circle. So go to 60 degrees and choose the y value. So that's going to be this guy. If you were to punch all this into your calculator, assuming it's in degrees, you'll jump to here. They didn't ask for exact or rounding, so there's both. This is the exact answer in the estimate. Approximation, sorry.
Okay, thank you.
I have a question. This might be dumb. So I put this in my calculator and I get a different answer. I don't know if I'm doing something wrong.
Is your calculator in degrees? It might be in radians.
Um,
What calculator do you have?
it's the TI 83. I don't know
Yeah,
if you can see.
go to mode and then check if it's in degrees.
It says degrees,
Let me see.
supposed to be.
You want to show me the calculator?
Yeah.
If I can
I
see it from here or not, but
don't know if you're
did you
opposite.
punch it in just like that? 28 times sine 60?
Yes. Um, hold on. I don't know if you can see on my screen.
No, I
Can you
guess
see
not.
it?
No, I
You
can't.
could put your hand behind it. Maybe that'll
Like,
help focus the image.
Let me turn off my thing. Yeah, you got 24. You have 14.
I did it both ways.
And they were both the same?
Yeah.
Well, maybe I made a mistake because I don't have a good. I was using my phone, so I don't have my calculator.
I was getting the same response. So
Okay.
yeah, I was like, I don't know if I'm doing this incorrectly. So
Let me pull up a better calculator. I trust y'all more than my stupid phone calculator. 14 times square root 3 is 24.25. Yeah, you're right. I'm sorry, guys. And what you told me now before we ended the class or something.
Yeah, it threw me off.
Yeah, I don't know if my phone was in degrees. Don't know. Okay. Alrighty. But anyway, the general idea makes sense though, right? You gotta draw the triangle based on whatever that you're talking about. Once you have the triangle, you choose the correct trig function. Then solve for whatever we're missing and punch it into your calculator. Those are the steps. Okay.
yeah, hold on.
Yeah.
Any other questions on 6? Okay. Let's do one more of these type and then we'll take a break. I'm gonna type the question in here. Well, no, I kind of want it here. So an observer on the roof of a 40-foot building measures the angle of depression from the roof to a park bench on the ground to be 24 degrees. Be 24 degrees. So I guess the visual would be you're on top of a building, you're looking down at an angle of 24 at the park bench. What is the distance from the base of the building to the bench as measured along the ground? This one does say round nearest foot. Okay, so 40-foot building. This is what I'm picturing at the moment. Let me draw that better. This angle of depression is 24. The height of the building is 40 feet, right?
Um, so just a question. Wouldn't the angle of depression be from the top of the building? Like it would be at the top of the building pointing down, correct?
Yeah, I think you're right. Let me think about that. Let me read this again. An observer on the roof. There's an angle from the roof to a park bench. Because, yeah, we're looking down. Hmm. That does make more sense to me. But let me double check. I don't have an answer key, so let me think. Um, Yeah. Yeah, because elevation would be if you're looking up at the building, depression would be downward. So this would be an elevation looking up. So I'm gonna go with yours and see if we get it. I think the answer should be around 90. We'll see how it goes. Okay. So if that's where our angle is, and we have the adjacent side, what function should we use?
We're looking for the adjacent side, correct?
We
Yeah, they
could
want to know the
use
distance from the
tangent
bench.
or cotangent.
Tangent would be, yeah, let's do that. Tangent of theta is equal to opposite over adjacent. So tangent of 24 degrees is equal to adjacent, opposite, which we don't know. This time, let's just call it x, I guess. X over 40. So solve for x, and we should have our answer. So x is equal to 40 tangent of 24. I don't have a calculator at the moment. What do y'all think?
17.8. Oh no, I did that wrong. Got a times. Oh no, I did do that right, I
Yeah,
think.
Is it
17.8.
in
And if
17.8?
you want to round to the hundreds place, 81 then?
Is it in degrees?
Yeah. Wow. I disappeared. That's fun. Yeah, it's in degrees.
Okay, what did you get, you said?
17.8, but if you wanted to round to the hundreds place, it'd be 17.81.
Interesting. Let me
Unless I
double.
didn't push a button somewhere.
I think you're right, but something's bugging me. Let me double check everything.
Question.
Yes.
When you have your initial opposite versus uh adjacent, would it be, is it not 40 over x
Yeah.
instead of x over 40? Which then you would divide 40. So would it be
We have our angle here, right?
mm-hmm.
So opposite to that angle should be here over the adjacent.
Oh, okay, I see what you're in.
So unless the angle is at the wrong spot, then it would be 40 over x.
Okay.
So as long as we put the angle in the correct spot, this is correct. I'm just the language of depression versus
Yeah, if they meant like depression, like it's eye level and then depression angle down.
yeah, that's what I want to that's what I think. But
And
okay.
then if that was the thing, then it might be the reciprocal that we use instead.
Reciprocal?
Yeah, where we use cosecant or cotangent, sorry.
Are you saying you would move this angle?
Um, so if the angle depression actually meant that like from the angle of eye level looking down, then your opposite would technically be the height of the building, and your adjacent would actually be from, parallel because it's a square looking at or thinking square. Then from your eye level, if the bench was on, let's say, hypothetically speaking, in the exact same distance, but also at the exact same height, then it would be the reciprocal to use. I did put a picture in the chat.
Let me see.
I don't know if that makes sense. Maybe that's why it looks weird.
Something seems off, but I'm not convinced just yet. But let me see what you got here. Maybe this will help.
That I might push a button
Observer,
wrong somewhere.
observer angle. 24. Man, it would be the same thing that we did, except that my line of sight would be the hypotenuse, which is still true.
Yeah, it'd just be flipping the square.
Yeah. Well, that shouldn't change anything.
No, I don't think so either.
Theta, because the opposite would still be, hmm.
Because
Yeah, I see what you're saying. The way I drew it would set it up like this, but your picture would set it up differently. So now I'm wondering, did I draw it? Did I read it wrong, and do we draw it wrong? Do you all
it's such
disagree
weird
with this
words.
picture? Oh, yeah, I know. Observer on the roof of a 40-foot building. From the roof to the point on the park bench. Hmm. What degree should be? I think it's since in my opinion, the paragraph doesn't really isn't that clear. I think the drawing's fine. And if it is, then this is our answer. But I don't have an answer key, so that kind of bugs me. But we'll let it go for now. All right, let's take a short break. It's 7:24. Um, Let's come back at 7:40. Okay, I'll be back.